Okay, I think that's right. Let u be the stuff inside the radical on the denominator. Where'd it go? 75. There it is. So 4 minus 9u squared. And then du is negative 18u du. So that's good because we have a u in the top. So that's a good fit. So we can put a negative 18 there to make, oh, shoot. Okay. I'm doing a u substitution on a u problem. So that's fine. I probably should use something else, otherwise I'm going to get mixed up. It's multiple choice, so if you want to continue to use u's, that's fine, but that's dangerous. I'm going to switch this to x and dx. So negative 1/18 out front. So now all of that is dx. Switching things up a little bit here. And the square root of x is in the bottom. Whoops, don't forget the negative 1/18. There's an answer choice with negative 1/18, but it's probably too soon to circle that and think we've got it right. And just circle it and go with it, huh? Oh, that's not going to be right because it's not going to be natural log. I'm going to increase the power by 1 and then divide by the new power, but that negative 1/18 is still there. So sine, it's not sine because there's a du in the top, so I think it's d. Yeah, there's my negative 1/9 and there's the 1/2, so yeah, it's answer choice D. What else?
76.
76.
I tried doing u substitution because I was like, oh, sine is cosine.
Good morning, Mustang. Teachers, if you are in a...
Okay, I agree, use substitution.
But then I just got u du, and I didn't know where that we're getting all those extra numbers and what the problem.
Okay, I think there may be a trig identity going on here.
That's what I thought too.
Which
then I went back to my sheet and I couldn't find it.
Kind of annoying. What did you let u be?
I said it was sine, so that way du was cosine and theta.
I like that. That way you don't have any negatives to worry about. Derivative sine is cosine. So that's definitely I think the easiest way to work this problem. And yes, you get the integral of u du, which is u squared over 2. So 1/2 sine squared of theta. And then, yeah, it's like, wait a minute, there's 1/2 cosine squared, and there's negative sine squared. What the heck is going on here?
Wait, where did the sine squared come from?
Because if I integrate u du,
Yeah.
I get u squared over 2.
Oh, and then it's, okay, got it.
And then I put sine back in for u, but this still doesn't match up. Well, I know that sine squared plus cosine squared is equal to 1. So if I replace, let's see, that means sine squared is equal to 1 minus cosine squared. So 1/2 1 minus cosine squared theta plus c. This is still not working out because that would give me 1/2 minus cosine squared theta over 2. And I'm not worried about the 1/2 because that could just be absorbed in the c. C is any constant, so the 1/2 doesn't matter. So I either need it to be a positive sine squared or a negative cosine squared, and instead both of those are wrong. Cosine of 2 theta and sine of 2 theta. This is the same trig identity that's needed in 78. Let's see. Cosine of 2 theta is cosine squared minus sine squared.
Could it have just been typed wrong? Unanswered choice D? Where it says 2 theta instead of squared?
Maybe, but I think it's going to end up being B, because let's see, this is such a pain. I can't believe they do this twice to us. 76 and 78 uses the same trig identity. Sine squared is 1 minus cosine squared, so this becomes 2 cosine squared x minus 1. So where were we? Here's my answer. Cosine squared is, I can replace cosine squared with cosine 2x over 2. I don't care about the 1 because that's going to go away with the plus c. So the 1 stuff's not going to matter. But cosine squared then is equal to cosine 2x plus 1 all over 2. So if I put all of that in for cosine squared, I end up with negative cosine 2x over 4.
I need to go back to square one. What is happening?
Trig identities, trig identity.
Class that we talked about Occam's razor. Yes. What happened to that?
Did we talk about that in this class? I don't think so, but
It was like, I don't know. But anyways.
okay. 78 uses the same trig identity, and there's no way you're going to get 2 problems that use that trig identity. That's
Wait, hold on. It's just cosine.
like, usually you just need sine squared plus cosine squared equals 1. That I get, okay? We should know that one. You use that one often enough. But cosine of 2x equals cosine squared minus sine squared, and then you rearrange things and you can get this.
That whole thing was so pointless.
And then you end up with, that's, yeah.
Yeah.
I said skip 78 because it's the same problem. You would replace cosine squared with, and plus there's a double angle in there, so it'd end up with a 4. Skip 78. It's too much trig.
How about 77?
No, it's nice. What?
77 is not,
I'm 76, so what are we doing for that?
for which one?
76, are we just ignoring it?
I'm not ignoring it. We got the right answer.
Yeah, but how did you get this?
I had to use this. So I got this answer from the integration. And then I'm using a trig substitution. Cosine squared is equal to cosine 2x plus 1 over 2. And if I plug all of that in for cosine squared, and I don't care about the 1/2s and the plus 1s, like the constants go away. They're all sort of absorbed into C. I end up with cosine 2x over 2 over 2, and that divided by 2 is where that divided by 4 comes from. Still don't like it. And that's okay. Awful trig.
So for this problem, you were more just solving it to find 1-4 answers instead of just...
I mean, this was way more about trig than about calculus. I mean, yeah, there was some calculus at the beginning, but to get from our first pass at the answer to one of the answer choices was a lot of trig.
I thought the answer choices were supposed to be like, just like, a final step in it. Like, I don't...
Right, this is definitely testing not just your calculus knowledge, but your trig knowledge. Because if they only wanted to test your calculus knowledge, they'd have left it as that answer.
Yeah, because I don't even like see...
Or maybe as this answer, because that's not too bad. But they intentionally jack those up.
It's like doing extra math to get the answer instead of like continuing the math, you know what I mean?
Right. It's like, why would they do that? You're right. I'm not here to defend College Board on that problem.
So anti whatever just happened.
Do we need to do 77?
Let's do it.
Yeah.
Okay.
The only last two that I think I answered is 77 and 81, so I don't know if we'll also have a problem with that.
What'd you try on 77?
I don't even know. It looks like I like.
And what did you
wrote
use
it,
for
and
you?
it was like,
I like U substitution.
I just tried.
you said didn't work.
Well, it depends on what you pick for you.
I did sine square root x.
For you?
Yeah.
Then DU is going to be a mess.
Yeah.
Yeah, it's going to be cosine and then times chain rule.
So just use square root?
Don't ever use just x, because that will just change all the problem from x's to u's without getting you anywhere. So don't ever let u be x, because that won't change anything other than the variable name. So let's try the square root of x, or x to the 1/2. Then du is 1/2 x to the negative 1/2. Which is 1/2 square root of x. So that top square root of x, I'm going to replace with u. But that bottom square root of x, I think I just want to put a 2 there with it to make it du. But then I need a 2 out front to cancel out the 1/2. So that's a tricky one, because it's tempting to put sine u over u and just replace that bottom square root with u. And that wouldn't be wrong, it's just you wouldn't be able to integrate it. It'd be stuck. So instead you see that bottom square root as being part of du. And then the antiderivative of sine is cosine, but negative cosine. And then let's see if that's one of our answer choices. -2 cosine square root of x. Yeah, answer choice B. $81, was that the other one? Yes. All right, 81. 81. Did you try something on 81? Because if you do U substitution for the bottom, you don't get the top because you're still stuck with e to the 2x. So U's not going to work. At least not letting you be the bottom. It does look like this piece is squared and this one's not squared. So I'm wondering if I can make it look like that, which would be inverse tangent. Again, that's just recognizing the problem. If we let u be e to the x, then that bottom would be u squared. Du is e to the x, so that would be the top. We're going to AB1, a squared plus u squared. So inverse tangent. So 1 over a arctan of u over a A is just 1, but we don't want to forget that 1 over a out front. So arctan of e to the x over 1. Inverse tangent of e to the x plus c. It's one of those, it's easy when the calculus teacher does it, because he recognizes what's going on. So this is why you need to spend 10 minutes a day with your derivative sheet, your stuff you must know cold sheet, so that you start to recognize, like, wait a minute, that looks like a format that I recognize, hopefully.